All right, so here's what I'd like you to do. I want you to skip down to page 58 before we go over some of the material in the previous pages. I want you to go straight to the instructor-led problems. I'll give you a second to do that if you haven't done that so far. So here's what we're going to do. We're going to solve these inequalities. And I'm going to show you that basically the idea of solving the inequalities is the same format as what we solve equalities. So when we have the equal sign, except for that little trick that when we multiply or divide both sides by a negative number, we have to flip the sign. Okay? So let's start with x minus 2 less than negative 4. So we have here x minus 2 less than negative 4. All I really have to do is add 2 to both sides. So let me put it this way. Just like in 1, 3, the left-hand side is as simple as it gets. The right-hand side is as simple as it gets. So we should add 2 to both sides. So I'm going to add 2 to the left-hand side. That's just going to give me x. And then I'm going to add 2 to the right-hand side. When I add 2 to the right-hand side, negative 4 plus 2 is negative 2. So there we go. We get x less than negative 2. Now, I don't have a coefficient, or I have an implied 1 as a coefficient in front of my x, so I don't have any division step. So this is the solution, or at least it is the algebraic solution to this linear inequality. I'll talk more about other solutions in just a moment. So let's do another one. Let's go to number 2 here. Negative w less than or equal to negative 12. So here, left-hand side again, right-hand side again are as simple as we can get, so there's no simplification. I don't need to separate the constants from the terms with variables because all of the terms with variables are on the left, all of the terms that are constants are on the right. So all I have to do is divide both sides by a negative 1. So I divide the left-hand side by negative 1, divide the right-hand side by negative 1. Now notice, this is a negative 1. I'm not dividing by a positive, I'm dividing both sides by a negative. So because I divide both sides by a negative, I have to flip the sign. So it's going to go from less than or equal to greater than or equal to. All right, so let me write that down. You're going to end up with W on the left, and then a greater than or equal to, and then a 12 on the right. Again, that's because, let me write that again. I divided the left-hand side, oops, wrote that poorly, and the right-hand side by negative 1. All right, so negative W divided by negative 1 gives you W. Negative 12 divided by negative 1 gives you 12. Since we divided both sides by a negative, we had to flip that sign. And so algebraically, that's basically the whole deal. Let's do one more just for sake of completion. Let's take this, negative 2m minus 5 less than or equal to 15. That's number 3. All right, here that problem is. So what we're going to do, simplified the left and the right-hand side. So we're going to add 5 to both sides. So when you add 5 to the left, you get negative 2m. When you add 5 to the right, you end up with 20. Then I'm going to divide both sides by negative 2. Again, since we're dividing by a negative, here's where that sign flips. So I'd get m on the left greater than or equal to, and this 20 transforms into a negative 10. All right, again, flipping that sign when I divide both sides by a negative. By the way, notice that adding and subtracting, neither of those change the sign. So I can add and subtract all the time. But when I divide by a negative, and usually that happens here in that last step, divided by a negative, I have to flip the sign, okay? So that's the idea. Now, in all of these problems, what I did is I solved this and got what we call the algebraic answer. The algebraic answer is where one side of the inequality is just a variable and the other side of the inequality is some constant number. All right? But that's not the only way to represent our solution. And that's what the other part of this text is talking about. So basically, the other part of this text talks about the ideas of representing our solution on an interval and on a number line. Okay? I think this is going to be a little bit easier to talk about when with those examples. That's why I wanted to do those examples first. And also, this is a little bit of weird notation. If you're in your book on this page here, I want you to just draw a circle, which is open right there, a circle, which we fill in. So let's fill this one in right there. Oops, that's bad. Circle where it's filled in. There we go. Probably a better idea. An open circle here, a filled in circle here. We call this filled in circle a closed circle. All right. So go ahead and do that to your book. Open circle with the less than and with the greater than, and then a closed circle with the less than or equal to and the greater than or equal to. So here's the deal. Here's our other formats that we can write an inequality in. We're always going to start with this basic inequality solving algebraically to get the algebraic inequality, x less than a, or x less than or equal to a, where a is just some number. But then after we do that, we're going to show on a number line and on interval notation what the solution is. So this is how we do it. Let's say x is less than some number. What that means is that x can be any number which is smaller than a. So this open circle, this is where a is at. Can't draw a very good a there, but this open circle is where a is at. And every number which is smaller than a is a solution to the equation. Now, when we say that in an interval, what we say is, well, a and below. Now, when we say below, how far to the left can we go? Well, we can go as far as we want. This goes on, this number line goes on forever. So it goes negative infinity to the left and all the way up to a. And those are the solutions. Anything from negative infinity all the way up to a. All right. Similarly, when we have x greater than a, we start at a and we go all the way to the right. So that goes from a to positive infinity. Let me do an example here with number line and interval notations using the inequalities that we just solved for. So let's take this. This says x less than negative 2. So what I would do is I would go to some number line. Let's say we have one there. And we'd, on some place on this number line, designate a spot for negative 2. Remember, our algebraic equation was x is less than negative 2. So our solution can be any number. In other words, what numbers make this statement true? Well, any number which is smaller than negative 2. Now, on a number line, that's any number to the left of negative 2. Now, we draw an open circle at negative 2, and then we put an arrow. Some people put this arrow on the number line itself, but because I'm drawing in Microsoft Paint, it's a hard thing to do. So I'm going to put the arrow on above. And what this is indicating is that anywhere from negative 2 and down, any number on the number line in here will be a solution to that equation. So that's the number line solution. As far as interval notation goes, we're going to go from negative infinity. We're going to go forever to the left. Forever to the left is negative infinity. By the way, infinity looks almost like a sideways 8. Not quite perfect, but you guys get the point. And then up, comma, negative 2. Now here's the trick. When you're dealing with interval notation, there are special parentheses you use when we have an open circle and a less than, and there's special parentheses we use when we have a closed circle with a less than or equal to. In this case, we have less than. That means I write an open circle. By the way, everybody who reads that knows mathematics realizes that open circle means that negative 2 cannot be a number that I plug into the equation. Since negative 2 can't be a number that I plug into the equation, I put a regular parentheses. All right, sometimes people call this an open parentheses so that it corresponds with the open circle. So open circle corresponds to less than, corresponds to that parentheses. And then negative infinity, it turns out, always has a parentheses on it. Same thing with positive infinity, because infinity is not a number you can achieve. In other words, you can't plug in infinity in for x because infinity is not a real number. All right. So there you go. This is the number line. That's the interval notation for this first equation here. Let me do another equation. Let me do number 2. And then number 2, I mean problem number 2. So we had this. W is greater than or equal to 12. So we're going to start with a number line again. And we're going to make a mark usually somewhere in the middle. And remember, it said W is greater than or equal to 12. So since 12 is kind of the unique number, we're going to put it right here. Again, notice that's the unique number after solving the equation, or after solving the inequality, I should say. Greater than or equal to, so this one we can plug in 12 in for W. So what we do, since we can have equality here, we make this circle and then we fill it in. Now I did that in Paint, so it's a little bit easier, but you guys get the idea. You just fill in the circle. So if we have equality, we fill in the circle. If no equality, we leave the circle open. Now W has to be greater than or equal to 12. So we need to plug in numbers which are bigger than 12. We need to plug in numbers to the right. Okay? I did that in two slightly different colors, but you guys get the point. There we go. So circle that's closed, point to the right. Interval notation, well, our interval notation, let me do it in this color here, is going to go from 12 to infinity. Notice I put 12 comma infinity. This means that anywhere between 12 and infinity, any number between 12 and infinity, you can plug in and make this equation true. Now, in the last example, we said infinity and negative infinity always have parentheses. So we write a parentheses where the infinity is. But because we can plug in 12, we want our readers to immediately know that plugging in 12 is okay. So the way we do that is instead of you writing a normal parentheses, when I can plug in the number, I write a square bracket, okay? So instead of a parentheses, if you can plug in the number, you write a square bracket. You can't plug in infinity because infinity technically is not a real number. So there you go. Now we have our algebraic solution, we have our number line, we have our interval notation. Let's do one more here. Let's do number 3. So we've already algebraically solved this and ended up with m greater than or equal to negative 10. All right. What was it? Yeah, we had greater than or equal to in the last problem, but that's fine. So m greater than or equal to negative 10. Let's go ahead and graph that on the number line and get the interval notation. All right, so m is greater than or equal to negative 10. Negative 10. So again, in a solved equation, negative 10 is the interesting number, so mark that down. Greater than or equal to means I need to draw a circle to the right. Now, ask yourself, do you fill this one in or do you leave it open? In this one, since we have the equal to, we got to fill this in. There's probably a good way to do that. There it is. So fill it in just like that. So we had a filled in circle. Make sure I got everything there. Pointed to the right because greater than or equal to, we got to point to the right. And then the interval notation, we start at negative 10. We go all the way to a positive infinity, which is just infinity. Parentheses always with infinity because I can plug in a negative 10 and get a true statement. I want to signify that with a square bracket. Okay, some people call this a closed bracket and this a closed circle because it's a filled in circle and we can plug in negative 10. So there you go. That's the idea. Now you've seen this all the way. You've seen the algebraic solving. Then you've seen the interval notation and the number line, all three. So in the next video, we'll do the rest of those problems on the instructor-led problems. Okay? Oops.